We talked in class about some of the ways that we can define a set of vectors, right? We could actually just list out vectors, but when we're talking about like a subspace or a subset of a larger vector space, usually listing out all the vectors is inefficient. And so we have one of the ways that we've talked about in class here, where we have a vector with a bunch of different elements listed, and then we have sort of a condition for those elements in that set notation, right? And so this question asks us which of these subsets is more likely to be a subspace. Subspaces need two things to be true, right? They need to be closed under vector addition, and they need to be closed under scalar multiplication. And in order for those things to be true, we have found that that condition, if we're writing our subsets in that way, has to be a homogeneous linear equation. And so while U is written kind of silly for us to see the homogeneous piece, it definitely fits that condition, whereas W doesn't. So if we wanted to write something, we write like, okay, U is defined by a homogeneous linear equation whereas W has nonlinear terms. Right, we could still set everything equal to 0, but we have nonlinear terms, y squared and z squared, or negative 4z squared if you want to be really good about our language here. Therefore, W is more likely, in fact, we know it's going to work, but we'll just say more likely because that's all they asked, to be a subspace. Boom. Be careful here. I had a lot of people say it has exponential terms. It does have exponents in its terms. However, our terms themselves are exponential, right? Exponential would be like a 2 to the x. So be careful with your math language here. Easiest thing is to just call out the fact that it's nonlinear, and therefore U, oh my God, I wrote W. U is more likely to be a subspace of R4 because U is this good one. Goodness gracious.